Hi, this is an introduction to interpreting regressions in Stata for the urban economics class at Harvard Summer School. The goal today is we're going to open up some sample data, so not the kind of data you're going to be using for the project. So I'm going to double click it right here and open up Stata, and then run some regressions like you're asked to do in the data exercise with the goal here of interpreting what the regression output means, because pretty much all the questions you're asked to do and will be graded on is for interpreting regressions. So just a quick introduction to Stata. I'm running it on a Mac. It looks similar on Windows. We have the review pane over here, which shows the commands you've used. So I've given one command to it to use this data set. We have our variables over here. On your data set, you're going to have a whole bunch of variables. For this simple data set, I only have 4. It's a pretend data set of like a class of people and their weight, their height, whether they're male or not, as a dummy variable, and their birthday. So basically, all the regression commands are always in the form of regression, and then, or reg for short, so reg for short, and then the variable that you want to predict. So for our purposes, let's say we're interested in predicting people's weight, and now we want to use the other variables to help predict this variable, to help predict weight. The first one we can try is let's predict it based on birthday, and intuitively, the birthday meaning like 1 through 31, so like what day in the month you were born on, probably doesn't help predict your weight at all, right? It's probably completely useless. And let's just verify that that's actually true. So we run a regression and we get some output like this. The first couple rows for our purposes are not useful, so you don't need to understand anything about source, model, residual, any of this crap over here. We're going to be interested in the stuff in this table. So you'll always have the variable that you're predicting. Here we're trying to predict the weight, and then the variables you use to predict it, and this final row, const for constant. So the constant is just like, if all the other variables were 0, what would we predict the weight to be? Here it's in pounds, so it would be 208 pounds. So I guess this is a fairly heavy class, or it's mostly made up of men, maybe. That row you're probably not going to do a whole lot of interpretation of. It'll always just be there. The other variables are what we're more interested in interpreting. So here we have birthday, and then we get a coefficient, a standard error, and a t-statistic. The t-statistic should ideally be big in absolute value. If you see it as a small number like this, like here it's 0.32, that basically says that predictor variable is a really bad predictor. That's a good sign here, because birthdays really don't predict your weight. If you were born on the 7th day of the month, you're probably not going to weigh any more or less than people born on the 20th day of the month, as far as I know. So it's probably a pretty good sign that birthday is not that important. The coefficient is the main thing we're interested in, though. So after we've assessed the t-statistic, we see it's either big because it's important or small because it's unimportant. We can look at the coefficient. And here, it basically, the way you want to interpret this is that for every 1 unit bigger this variable is, the predictor, so birthday, the coefficient is going to tell you how much bigger the y variable, the one you're predicting, gets. So when birthday goes up by 1, the weight, the thing we're predicting, goes up by 0.0955. So basically it's saying people born later in the month weigh a tiny bit more on average in this data set than people born earlier in the month. But it's effectively 0, and that makes sense. That's not too surprising. So we can do some other regressions where we'd get more meaningful results. For instance, if we were weight, so we're trying to predict weight still, but we predict it based on height, we get a result like this. Now the t-statistic for height is really big, and it basically says for every 1 inch taller you are, so every 1 unit bigger height, you weigh 8.88 more pounds. That makes a lot of sense, right? Taller people are going to weigh more, so these data seem like they're pretty good data. If you did this regression and you got that for every 1 inch taller, people weighed 10 pounds less, it was a negative number, or there was just like a 0, so that height and weight didn't matter, that would be kind of weird. You might have loaded something wrong. You don't have to do just one variable at a time, so Danny's going to ask you to use multiple variables to predict income. Here we're predicting weight for all of our examples, but I think you're predicting income for households in the exercise for all the regressions. Say we want to predict your weight based on whether or not you're male and your height. So then we can interpret here. Again, we have for every inch taller, now we say you weigh 2 pounds more, so that still makes sense. And then if you're a man, then this variable male will be a 1. If you're not a man, it would be a 0. So if you went from being female to male, is how you can think of it, you would weigh 93 pounds more in this data set. That seems kind of big, but it's positive, and that makes sense, because we think a man who is 6 feet tall probably weighs more than a woman who's 6 feet tall. You know, all else equal, men weigh more than women usually. Finally, the last thing that you're going to need to be able to interpret is sometimes we do interactions between variables. So instead of just using your height or just using whether you're male or not, we can generate a new variable. I'll call it interaction. That's the product of the two, so height times male. And you'll have to do this on the Stata exercise. It tells you how to create these variables, but you'll need to interpret them. And now we can regress weight and try to predict, how does your height affect your weight? How does being male affect your weight? It's really not the effect, it's just the association. It's how does being taller predict your weight? How does being male predict your weight? And then how does the interaction between the two predict your weight? So here we have, again, being taller, you tend to be heavier, being male, you tend to be heavier, and then we have this interaction variable. That's the hardest one to interpret. The way you want to interpret the interaction is it's basically saying there's an effect of height in general, and then the interaction shows the effect of height for males only. So for a woman, for every 1 unit taller you are, for every 1 inch taller you are, your weight tends to go up by 1.6 pounds. The interaction, since it's height times male, says the special effect for each 1 inch for men, in addition to this general 1.6 extra pounds, there's an additional 0.848 pounds. So for a man, you're going to get the effect from your height, the effect from being a man, so it's 35 more pounds because you're a man, and then in addition, you're going to get this interaction effect that only applies for your height because you're male, that says for each inch taller you are, you get 0.848 extra pounds. So basically the way we're using this prediction is saying there's an effect of height for women, there's an effect of being male in general, and then there's an effect of height in particular for men that says for each extra inch for a man, you not only get the 1.6 extra pounds, but you get the 0.848 extra pounds. That probably made no sense. There is a reading that I'm going to post on Canvas, so where is it? Notes on regressions, that basically goes through this, trying to explain it in words with similar tables. The numbers are different because the data set's different, but it goes through the same exercise of predicting weight based on your height and your gender and the interactions and stuff like that. So if this video didn't help, maybe the reading will help, and if that fails, you can just send some emails. So it was great to thank you for watching this video. Hopefully it helped. If not, email. Thanks for watching.